The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone and welcome to the webinar. My name is Jamie Wallace and I work here at Redgate Software in Cambridge in the UK. And today I'm joined by Bob Pusateri, who in a moment is going to talk to you about the impact bug patching can have on your SQL Server performance and how a monitoring tool can help. Bob has been a friend of Redgate for 5 years now. He works at Heraflux Technologies as a solutions architect and has over a decade of DBA and developer experience. You may know him from his Twitter handle, SQLBob, or read his popular blog at bobpusateri.com. If you have any questions during the webinar, then please send them in via the question box, which you can find on the right of your screen, and we'll answer as many as we can at the end. So, without further ado, let's cross live over to Chicago and hand over to Bob. Hi, Bob, are you there?
I am here. Thank you very much, Jamie, for that wonderful introduction. And hang on a second while I share my screen.
Okay, we can see you.
Okay, it's on? All right, excellent.
On,
All right,
yeah.
Thank you everyone for joining. And thank you, Jamie, again for the introduction. So we're talking about bug patching today, and I thought a great demonstration of that would be the recent exploits for Spectre and Meltdown. So we're going to give a brief introduction into exactly what those are and how they affect you. Start as a background by talking about CPU modes. The CPUs in your computers operate in generally two different modes. There's kernel mode and there's user mode. Some architectures actually have 3 or 4 user modes, but basically every CPU you can find today has at least these two. These are in place to give a layer of protection to your applications. They are implemented in hardware, and they are operating modes that can restrict the permissions of different processes. Certain parts of your operating system need to run with a higher level of privilege within the CPU than others, and that is what these modes facilitate. So the first mode we have here is called kernel mode. It can also be known as privilege mode or master mode. Sometimes it's called supervisor mode as well. But whatever you call it, kernel mode is the unrestricted mode. If you're operating within kernel mode, you can do anything. You can access memory at absolutely any address belonging to any process. You can also utilize any resource belonging to the system, no matter what the device is. Generally, a very small part of computer code actually executes in kernel mode. Kernel code is a rather small portion of the operating system. It's usually highly trusted and regulated. And ideally, that is the only code that will ever execute in kernel mode. In real life practice, you'll find a couple more things that execute in kernel mode. Most commonly, device drivers will do this. Device drivers need very quick access to system resources, such as the devices they're controlling. And sometimes performance is significantly better if they can just execute in kernel mode the whole time, even though that's not ideal. Aside from kernel mode, then we have user mode. User mode is restricted, whereas kernel mode is not. Only a subset of kernel mode's operations are allowed within user mode, but the vast majority of what your computer does will execute in user mode. Basically, any application you run and the majority of an operating system also executes in user mode. There's no need for a lot of what your operating system is doing to run in kernel mode. If you're running an application that's in user mode and you need to access kernel resources, this is where you make what's called a system call. And the system call makes a request to the kernel to perform some type of kernel mode operation on that user mode process's behalf. So if you're running a program and you're saving a file to disk, you need to access a disk. Disk is a system level resource, and that disk access will execute in kernel mode as the result of a system call. If you're working with processes, if you need to create a new process, also known as forking a process, if you need to schedule a process or tell a process to sleep, these are kernel mode operations. Additionally, if your application needs to access the internet or go through a network card or another system device, these are also kernel mode operations that have to be made via a system call. So that's kernel mode versus user mode. The specific feature of a CPU that gets exploited for the Meltdown and Spectre attacks is actually called branch prediction. So we'll talk about this briefly. Your CPU likes to maintain a pipeline or a queue or a list of instructions that it has to execute, an ordered list. It likes to know a couple steps ahead of the game what instructions are coming down this pipeline, because occasionally there's optimizations that can be made as a result. And this is all well and good, and it's usually very easy to read ahead in a program and see what's coming next. But the problem shows up when your code contains a branch. So for example, if you're running a segment of code and you come across an if-else statement like this, the CPU doesn't know what's going to come next. It won't know until that moment what the value of the variable y is. So it won't know if y is equal to 0 and it's doing one thing, or if y is not equal to 0 and it's doing something else. This creates a problem when you're trying to maintain such a pipeline. So what CPUs will tend to do is they will predict. This is where branch prediction comes in. It will make a very educated guess about what's going to happen, about, in this case, the state of the variable y. And as you can see here, if it believes that y is equal to 0, then it is executing the command x equals b times 5, but if y is not equal to 0, maybe it will execute b plus c instead. So let's pretend that our branch predictor has determined that y will not be equal to 0. If it believes y will not be equal to 0, and we know the values of variables b and c in advance and don't believe they will change, or know they won't change, then we can execute this b plus c operation in advance and have the results ready and waiting, so that as soon as we know that y is in fact not equal to 0, we have this result ready to go. This is called out of order execution, or in engineering circles, it's also known as dynamic execution. Either way, you get a speed boost by attempting to predict the future, do work ahead of time, and have it ready to go. This works great as long as you guess correctly. And most of the time, the guesses are correct with branch prediction, but occasionally they won't be. And at that point, we now have to undo the work the CPU has done. This is very similar to in a database. If we do something wrong in a database, we can roll back a transaction and bring the database back to a consistent state. The CPU will more or less do the same thing to bring itself back to a consistent state. However, a CPU's rollback isn't quite as complete as a database's. So in this case, if we have b plus c calculated, ready to go, sitting in memory, the CPU's cache, which is also known as a register, and then it turns out we don't need that result of b plus c, and the work is undone, that result is actually not deleted. It's left to sit in the register, just unused. Now, if b and c are simple numbers or something that doesn't matter, this isn't a big deal. But if b and c were the result of system calls to protected kernel processes, we would now have protected kernel level data sitting in a place that's accessible by user mode. And this is more or less exactly what the Meltdown exploit is. So when this occurs, if this data is available and if you access it, this is what Meltdown is. It will allow the CPU to return this private kernel mode data from user mode. This can expose different applications on your machine. This can also expose different virtual machines if you're running virtually. And if you know anything about virtualization, generally you want virtual machines to be completely isolated from each other unless they're configured not to be. So this is horrifying in terms of virtualization. This affects most Intel CPUs that have come out since 1995, which is where dynamic execution first made its appearance. There's some exceptions. Itanium architecture works differently. If you had an Atom processor before 2013, it doesn't have this feature. IBM Power processors have this as well as some ARM devices. So if you got mobile devices with an ARM processor, you could be exposed as well. AMD processors are not vulnerable to Meltdown. They have a different architecture in place that does not allow this exploit. Now, Spectre is slightly different from Meltdown, but works along the same lines. Instead of dealing with user mode and kernel mode, it is a different type of exploit that allows one process to access another process's data. The issue with Spectre is it's not a specific vulnerability, it's actually a whole class of them. There's different ways to exploit the behavior of Spectre. And this affects all CPUs identically. So if you have Intel or ARM or AMD or IBM, you're vulnerable to Spectre. It's a more difficult exploit than Meltdown because it has multiple vectors. As I said, there's multiple ways to exploit it. And then because of that, it's harder to fix. So what caused Spectre and Meltdown? Well, as I said, they're architectural flaws primarily. They're side effects of these design features of branch prediction and dynamic execution. And they've actually been present since these features were first introduced, which, as I said, was about 1995. It's really quite remarkable when you think about it, that this flaw existed for over 20 years and was only noticed recently. So how do we fix it? Well, the ultimate fix is a hardware redesign of the CPU. This will involve designing a new CPU physically and implementing it and getting these new CPUs out to people. Until then, we're left with software patching. Operating system vendors are putting out patches for this. And we've been told to expect these patches will reduce performance. We're doing extra work now to try to mitigate this threat. Doing more work will always take more time than doing less work, so there will be a performance hit involved. For all we know, the CPU hardware redesign may reduce performance too, but as far as I know, no redesigned hardware has made it into any level of testing yet where we would know that for sure. And as an aside, I actually have a degree in CPU design, computer engineering, and that photo you're seeing on the slide right now is from one of my class projects where we actually had to implement processor pieces on silicon. So what if you don't fix Spectre and Meltdown? Well, then you're going to be vulnerable to this exploit. And I will admit it's highly unlikely that you could actually suffer a data loss from this exploit, but it's still a liability. Organizations are generally extremely risk averse, especially the legal department. So with a vulnerability like this that received such high visibility in the news, I cannot imagine any organization would want to be known as not patching to reduce the risk of Spectre and Meltdown. So then the question comes up, if you're doing this patching, how much will it affect your system? Right, and this isn't just a Spectre and Meltdown question anymore. This can be patching in general. If we're applying a patch, how much does it affect our system's performance? Does it get better? Does it get worse? These are great questions, but you need objective data to really be able to answer them. Do you know how your system is performing today? And not just that it performs well, do you know objectively? Do you have numbers to back this up? Data collection is a great way and more or less the only way to achieve this result. And that's why we're here today to talk about Redgate SQL Monitor. So I'm going to switch to my Redgate SQL Monitor screen here. Here we are in Redgate's public preview of Redgate SQL Monitor. You can actually access this on your own machine at monitor.red-gate.com. And we're looking here at some custom metrics. So we're looking at a metric for SQLServerCentral.com. This is actually monitoring the servers, powering SQL Server Central right now. And we're looking at a metric of forum posts per hour. So if you're looking to apply a patch, probably one of the first questions you'd want to ask during your planning stages is, when exactly do I apply that patch? Right, and you may have an idea of when your environment has the lowest level of activity, or maybe you have a defined maintenance window, and that's even better. But if you're trying to determine that lowest level of activity, this is one of the first places metrics can really help. So we have here the number of forum posts per hour for the past week, and you can see that the number of posts kind of has an ebb and flow throughout the days. And it gets rather low on the weekend. And looks like Saturday evening into Sunday morning, there's practically zero activity at all in this window right here. So if I was looking to apply a patch for Spectre or Meltdown or anything else, this is exactly where I would want it to be in this period of very low activity. So as you can see, collecting this data in advance, we can make excellent determinations just based on things we have already. So we're collecting this data. We determined when we are applying our patch, and we apply our patch. Now the question comes to, how did this affect our performance? And again, if you're collecting this data, you'll have this information at your fingertips. So we'll go here to SQL Monitor's analysis feature, and you'll see we have a graph pop up, and this is for one of the database servers powering SQL Server Central.com. We're looking at a cluster with 2 machines. They're marked by the red and the blue lines here. We're actually going to just focus on the blue line, the more active machine in the cluster. And we're looking at CPU performance for the past hour. SQL Monitor actually keeps this data for up to a month, so we're going to expand out and look at the past week instead of the past hour. So here's our CPU activity over the past week. What if we applied the patch for Spectre or Meltdown last week? How did this affect performance? Well, since we have a baseline, we can compare to it. So if we hit the compare baseline method button, you'll see it actually throws a second line up on the graph, a little bit paler blue there, but that is the CPU performance of last week. And now we can very easily and objectively tell that, yes, our CPUs are running about 10% hotter on average this week than they were last week. There's no arguments that can be made when you actually have numbers to back up something like this. So you would know instantly. And that's another great feature of SQL Monitor. From here, we have this data. We can also use this data to make predictions, right? Ideally, that's not too hard to do once you have the data to go on. So if we go over to alerting, you'll see we have an alert set up here for database file usage, and the database file usage alert does just that. It's actually trying to make predictions on when a database file will have to grow. So if we click on the latest instance of this alert, you'll see in our chart here, we have a blue background, and this blue background actually represents the size of a database file on disk. And you'll notice the file has done some growing, so we have some steps here in the file size. The black line is the size of data in the file. So as the size of data grows and approaches the size of the file auto grows, and then the data grows, and this happens again and again. SQL Monitor is able to predict here the next time a file growth will occur, which if you look is predicted to occur on March 29th. So we have a little over a week before the next time this file will need to grow. You can either do nothing about this alert and let the file grow by itself, or maybe if your organization likes to pre-grow files so that auto file growth doesn't happen, you'll know you need to pre-grow this file in the next week. SQL Monitor also will help you out here and tell you that based on the last month of growth, if you were to size the file with a 356 megabyte increase, then you wouldn't need to touch this file again for a year. And if you'd like to grow your files really far in advance, you have the information to do that. Circling around to more of the alerting features, if we go back to the general alerts page here in SQL Monitor, and we clear this one, if you've used SQL Monitor before, you'll know how this works, but if not, allow me to explain. When an alert fires in SQL Monitor, your alerts go into this page here, the alert inbox. Think of it kind of as like an email. It produces a list of you of things to check on that need reacting to. Maybe they involve actual intervention, maybe they don't, but you're alerted through this alert inbox. In previous versions of SQL Monitor, you would receive one entry in the inbox per alert. So in this case of the top alert here of long-running queries, it says there are 65 of them. That means that you used to receive 65 individual alerts. Now with SQL Monitor, it's actually grouping these alerts for you, so you don't have this massive inbox like you used to. It's telling you there's 65 long-running query alerts, there's 15 deadlock alerts, 239 of a different type of deadlock alert. It rolls them up for you, very helpful. And if we were to click on the long-running query group, we'll see the list of specific alerts that triggered, and then we can dial in and actually tell exactly what triggered, what was executing at that point, what were the conditions like in the environment when this alert filed. These are the alerts that are built in. You can also create your own alert. Custom metrics are very powerful in SQL Monitor. Essentially anything you can write a SQL query for, you can create an alert. So if we were to look here, for example, at the metric of user errors per second, we could see that, yes, we have a SQL query here, and you can go ahead and run this in SQL Server Management Studio or the client tool of your choice and get a number back. But this is exactly the query that SQL Monitor is using to create its metrics and base alerts from. Similarly, you can set different thresholds for your alerts. If we were to go back to our list of existing alerts that are configured in the system, let's go to processor utilization since we were looking at that earlier. You can see you can configure what happens when an alert fires, what level is it of an alert is it? Is it a low or medium or high? What threshold triggers that alert? If you'd like multiple thresholds per alert, you can configure a threshold for each, the low and medium, high level, depending on what you'd like. And then you can choose what occurs when that alert fires. Do you notify someone? Do you not? Etc. So I hope I was able to show you briefly, at least, the value that you can extract from data being collected over time. Not only can you make predictions and trigger alerts, but you can objectively identify changes in your environment's performance, whether that is related to patching or any other type of events. Remember, the only constant in your environment and in life will be change. So looking beyond Spectre and Meltdown, I fully expect these exploits to just keep coming. The methods of detecting them now are extremely advanced. It would not surprise me if this is not the only deeply hidden exploit we find in a CPU in the next year. In fact, just last week, a new flaw was announced affecting primarily AMD processors. So this stuff is still coming. The patches and the fix will continue to come until these processors are redesigned, and I'm sure this will be more or less the new normal. Similarly, if you're in organization is affected by GDPR, this is another area where performance really matters, and alerting will help you. The GDPR states that you must report any personal data breach within 72 hours of becoming aware, and if someone makes a request about the data you're storing about them, you must confirm whether or not you're storing data about that individual or that organization as soon as possible, and must be able to provide that data within a month, or else you'll face stiff penalties. If you're being slowed down by a vulnerability or a patch, there's no provision in GDPR for that. You may be at risk. So you really want to be on top of your environment, your performance, and your availability. To sum things up, Redgate SQL Monitor can help you with all of this. Not only can it quickly and simply collect performance metrics and display them for you very easily in a format that's quick to understand. It will automatically establish performance baselines for you. It can alert you on changes in your performance, and it can keep you ready for that next round of patching, whether it comes at a scheduled interval or not. And at this point, I'd like to open up. Do we have any questions?
Thanks, Bob. That was really interesting. And yes, we've had some questions come through while you've been talking. So I'll read them out on behalf of the people who've been asking them, and hopefully you'll be able to give a good answer. This first one from Dave, I think this was kind of covered already when you were talking about the ongoing vulnerabilities that we're likely to expect. But he said, do you think this is going to be a pattern now for the industry? Are we going to continue to see vulnerabilities in processors and other areas? And is it something we need to get used to?
I would unfortunately answer that with a yes. I think that vulnerabilities are going to keep coming because the methods of detecting them are getting more and more advanced. Years ago, vulnerabilities may have been present, but the exploits for them were so complicated that they couldn't really be utilized. Now computing is getting to the point where it's easy to do this stuff, unfortunately. So yes, I would say this is something you need to keep ready for at all times.
Yeah, I agree. And I think the more you know about your estate, on an ongoing basis. Now, SQL Monitor is great at looking back at history, but if you're keeping on top of everything, you're going to see these vulnerabilities occur much quicker than if you're just going to it after the problem happens. So it's about proactivity rather than just firefighting.
Absolutely.
Okay, so Fred has asked, are there any good strategies for updating BIOS in case of bricking? Can you answer that, Bob?
Any good strategies for updating BIOS in case of breaking?
Yeah.
I'd like to say be very, very careful. Most of the machines I've worked on, at least, when I've had to do BIOS updates, have actually had 2 copies of the BIOS, and that's provided for safety. So you would update the one and then boot from that one and then update the second one. And so if you do cause a break, the idea there is you still have a second copy of an older version you can boot the machine from. Beyond that, that is a infrastructure level activity that I haven't participated in as much. but that's what I do know of it.
Okay, great. Steve's asked, there's lots of alerts going on, and you showed the capabilities that SQL Monitor has in creating new alerts as well as using the existing ones. How do you stay on top of them all? I think I can actually answer that one, Steve.
Okay.
As Bob showed you in the presentation, SQL Monitor now has grouped alerts, which brings down the volume of alerts that you're seeing quite significantly. So that's one thing that's going to help you keep on top of them. You can quickly see which ones are the most urgent, dive into those, and you don't have to scroll through lots and lots and lots. But SQL Monitor also integrates with email, so you can set up email alerts that can go to your team or a specified inbox or something like that, and that's going to help you keep on top of them too. And it's got Slack integration too. So if your team use Slack, then you can set up SQL Monitor to alert you via Slack. So there's lots of different ways of keeping on top of these things. You don't just have to always be on them and looking at them. We've got a question from Biju here, which says, once the new CPU hardware fixes are found and manufactured, does the manufacturers expect everyone to buy new servers? That's a good point. What do you think to that, Bob?
Yeah, that's a great question. I'm going to say I highly doubt they will expect you to go out and buy new hardware right away, especially when patches have been issued, and hopefully those patches will be effective in mitigating this problem. So I'm sure we'll see people running CPUs that have this vulnerability in hardware for probably the better part of the next decade at least, and that's assuming that these newer CPUs with the fix implemented come out later this year, as have been predicted. But I think it's going to be a while before we get to a point where that hardware is the minority that has this vulnerability in
it. Chris has asked, do we have any generalized performance difference between having the SQL patch applied versus the OS patch versus the hardware firmware versus a combination of such? So yeah, I guess is one of those going to cause performance issues, or is it a combination of all of them together?
I would argue it's a combination of all of them, and it's gonna heavily depend on your environment and your workload. So there's no blanket answer for that. And some of the brief testing I've done, I've seen performance hits, but I have not fully tested enough environments to really have a good generalization at this point.
Yeah, I think you're right. I think a lot of it is knowing your environment, knowing what you consider to be normal behavior, and then being able to react when that changes. Brian asked, do VMs need to be patched, or are CPUs of VMs pipeline like physical CPUs?
CPUs in VMs are indeed pipelined like physical CPUs. So if the patch is at the operating system level, then you would in fact be patching in the guest operating system. I believe that the virtualization vendors as well have patches for the underlying operating system that runs, but I have not personally applied those at this point. That's not something I typically work with as much.
Sure, yeah. Amy's asked, can I generate reports based on the data I'm seeing in SQL Monitor? I can grab this one.
Okay.
Yeah, there is a whole report section within SQL Monitor. You can customize that to generate reports on all the data that you're seeing. And I think that's one area that we like to learn from our users as to how they're using reports. So our development team are very active in interacting with users and finding out how they're using the product and how you would like to use it better. So if any of the things you've seen today, if you're using SQL Monitor, if you want to go and give it a go, if you want to get in touch with the development team, they really appreciate that. So you can email SQL Monitor feedback@redgate.com and give feedback on any of that. And yeah, if you're generating reports, we'd love to hear how you're using them. Okay, we've got time for a couple more questions. Chris asks, how important is installing the SQL patches if you have the OS patches?
Sorry about that. I was on mute.
Oh, right.
Yeah, I do believe you need to install both. Again, I have not fully applied patches to the point where I have understood exactly what they're patching at the SQL level, but I would expect you need both of those.
Great. And Scott asks, have you heard any cases where patching for Spectre and Meltdown have caused any serious performance issues with SQL Server in particular?
I have not heard of serious performance issues. I have heard of performance hits, but I have not heard of significant hits. I have not heard of performance tanking by 30% or anything like that. But again, you're doing more work. Performance will be affected. Unfortunately, it's just there's no free lunch in computing. So
Yeah, exactly. And yeah, I think that comes down to, again, I think the expectation with this patching is they say it is going to affect performance. And so depending on the setup you're running, if you've got a lot of room for extra load, then fine. But if you've not, then that could cause a serious issue and that could cause some outage. So yeah, I agree. I've not seen any really bad cases, but yeah, it's always going to be there lurking, and hopefully as people do their patching and keep an eye on their servers, they're going to see hopefully not see any problems.
hmm
Scott says he's used SQL Monitor for years and years and loves it. Thanks very much, Scott. Okay, so I think that's all the questions we've got. So I will just I'll swap back over to me and I'll do some final slides.
All right.
Second. Okay. So thanks everyone for watching. I want to say a huge thank you to Bob for taking his time to talk to us today, and thanks to all of you for watching. As I say, if you'd like to discuss your SQL Monitor options in more detail, then you can contact us by email at sqlmonitor@redgate.com, and you can experience SQL Monitor for yourself. If you go to redgate.com/SQLmonitor, you can download a 14-day free trial, and you can also try it live online. Monitor.redgate.com gives you a live environment exactly the same as you've seen Bob using today. And finally, I just want to talk to you about the State of SQL Monitoring survey we're currently running. We want to learn basically how the current way of monitoring your SQL Server estates is working, what tools you use, or if you use them, do it manually, how long it takes to run, and complete tasks and to fix problems. It will take between 5 and 10 minutes to complete, and as a thank you for doing it, we will be sending all participants an advanced copy of the report when it's published in April. Plus, everyone who completes the survey and provides their details at the end will be entered into a prize draw to win a $250 Amazon voucher or equivalent in your local currency. To take part, you can visit the link that's on screen at the moment, surveymonkey.com/r/stateofmonitor. And this is open until the 31st of March. So if you go there now, you'll be able to enter your details and let us know how you're currently monitoring your SQL Server estate. And that's it. Thanks very much for watching, everyone, and thank you to Bob. Goodbye.